this. Nope, 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 nope. We are looking at ways that you can prove triangles similar today. So as a refresher, and this is going way back, when we were talking about triangles being congruent, you had actually 5 different ways to prove triangles were congruent. So if you guys recall back, you could use side, side, side. You could use side, angle, side. You could use angle, side, angle. Or you could use angle, angle, side. Or that one random case with the right triangle, you could use HL. That's when you were proving triangles congruent. So today, what we're going to look at is what about when we have triangles are similar? And so you're only going to have 3 options for when triangles are similar. The first one is dealing with just angles. Now remember, the reason we couldn't deal with just angles when we were talking about triangles being congruent, if you think about the most basic of an equilateral, you could have a really tiny equilateral triangle, all angles are 60 degrees, and a really big equilateral triangle, again, all angles are 60 degrees, and those triangles would not be congruent because they're not the same size. However, for similarity, they don't have to be the same size. So we are going to be looking at one method called AA, and the reason we don't have 3 A's there is because if you show 2 angles are congruent in a triangle, the third is automatically congruent since all of the angles equal 180. So again, AA works, and that takes care of this concept here and here. You also have what we call side, side, side similarity, and you have side angle side similarity. So really they kind of match up nicely with these. We're not going to worry too much about the HL piece when we're talking about triangles being similar because it will be grandfathered in with one of the other 3 that we already have established. Now, the big key for this, and I'm going to kind of come back to this, is again, guys, angles have to be congruent and sides have to be proportional. We've talked about this already. We talked about it in yesterday's video. And we have to show both things if we're going to be using like side, angle, side. We have to show the angles are congruent. We have to show that the sides are proportional. It is not enough for the sides to just be labeled. Let me say that again. It is not enough for just the sides to be labeled. You have to show proportionality. So let's take a look at some concrete examples here. So proving triangles are similar. So first off, right here, we're using angle, angle. So again, just a reminder, the angles have to be congruent. So what we see here, we don't see any angles actually labeled, but what we do see is we see the intersecting lines here and here are automatic. You also see that you have parallel lines here and here. So if you think about those, that N that we've talked about in the past, you've got an angle tucked into this corner and this corner that are also congruent. Okay, now technically you could use the other transversal of this DF, but you don't need to because right now we've already shown that we have those 2 angles are congruent. So we've got, yes, they are congruent by angle, angle, and I know the directions doesn't state to go ahead and write a triangle similarity statement, but we're going to get in the habit of doing so just so we have that practice. So we have triangle ECD is similar to triangle. So E matches up in the other triangle. We already established those were vertical angles. We've already established that these are alternate interior. So C is going to match up with G, and then you have F for your final angle. Okay, moving on to number 3. We're going to do the odds together today. If you notice, we have one angle here already given to us that matches. So we're partway there. Now, the only thing is the 39 and the 51, while they don't match, we can figure out this angle S by doing 180 minus 90 minus 39 to get 51. So again, we can use the idea that those angles all add up to 180. And now we do have that second pair of angles here. So we would say yes, by AA, we could show that triangle, and we could do it in any order. I'm just going to do YES is similar to, and Y is the right angle, so it's going to correspond with C. E is your 39 degrees, which we didn't label in the other triangle, so H, and then W for that last piece. Okay, if we take a look at number 5, we have these overlapping triangles. So again, anytime you have overlapping triangles, I'm going to strongly suggest that you draw them out separate, just to kind of see what we're looking at. So you've got L, M, and N. You've got B, C, and N, and I'm going to label what I know so far. So I know that these are both 67 at angle N. And again, right back to kind of what we did in the last example, we can figure out, even though we only have one pair matching right now, we can do 180 minus 67 minus 25 to get this angle up here at angle M. And so that is going to be 88. So now we can see that we only have the one angle of 67 that matches. So we would state that this is not similar. Okay, you could use the abbreviation for similar if you want, but you do not need a similarity statement if they are not similar. Stating that they are not similar is enough. All right. So let's take a look at the next type. So the next type is side, side, side similarity. So what we would have to show for side, side, side is that your sides are proportional. In other words, you are going to have to check some fractions. So you're going to say, okay, is this fraction equal to this fraction equal to this fraction? Are those equivalent? If that answer is yes, then you're good to go. So when you're looking at these, you need to be careful how you're matching things up. So for example, 9 is our smallest side here, 14 is our smallest side here. 27 is our largest, 42 is our largest. So that means this one automatically is the middle. And so now I can go ahead and set up, and I can say, okay, I'm going to set up 9 over 14. I'm going to do 13.5 over 21, and I'm going to do 27 over 42. And we need to see, are those equivalent? So what I would do is just type it in my calculator. I would do 9 divided by 14. That gets me approximately 0.643. I would do 13.5 divided by 21. That gives me about the same thing. I shouldn't say about the same thing. It is the same thing. And then I would do 27 divided by 42, which is going to give me the same thing. Now, they have to be exactly the same. And if you actually do it on your calculators, you will see that they are exactly the same. And so because they're exactly the same, we would say yes by side, side, side. And then you would say, okay, I'm going to go ahead and do triangle KNR is similar to, and K over here is where the boxed one and the underline come together. So box, underline comes together at D. N is our obtuse angle when we look at that. So E matches, and then we've got S. And so we have to check this. And so let me just kind of revisit this really quickly. If it is close but not exactly equivalent, close does not count. Okay, so it has to be exactly equivalent for this to work. All right, so let's take a look at number 9. Number 9, we look at this again. We're going to pair up our small sides. So 5 is our smallest side, 3 is our smallest side, 16 is our largest, 10 is our largest, and then you've got 12 and 7 match. So I want to say, okay, does 5 over 3 equal 16 over 10 equal 12 over 7? Okay, are those equivalent? And so when I go ahead and type those in my calculator, 5 divided by 3 is going to give me 1.6 repeating. 16 divided by 10 is going to give me 1.6. And I can stop right there because I can see that those two are not exactly the same. And because they're not exactly the same, I can state that they are not similar and I can move on. So let's take a look at number 10. Number 10, be careful with number 10. There is a weird way that this printed. This is actually all one length, this 14.4. That's our shortest side in that triangle. So 8 is our shortest side here. 17 is our longest. 30.26 is our longest. And then we have 15 and 27. So as we look at this, we've got 8 over 14.4. We're going to see, does 15 over 27 match up? And the last one, 17 over 30.6. And so again, all I'm doing is punching these in my calculator. So 8 divided by 14.4 gives me a value of 0.5 repeating. 15 divided by 27 gives, 15 divided by 27, helps if you guys type the right numbers. There we go, is 0.5 repeating. And then 17 divided by 30.6 is also 0.5 repeating. And so since those are all exactly the same, I could say yes by SSS. And then for my triangle similarity, I can do YZX. Y is the angle that looks pretty close to a right angle, so that matches up with W. Z is moving along the short side, so moving along the short side, I go to R, and then V. Okay, now the last one is probably a little bit more complicated for some people because you have to have the side angle side pattern to start. Then you also have to check your sides. So for example, I have to do both the sides and angles. Okay, so I have to check that the angles are congruent, and I have to check that your sides are proportional. Okay, so we do have the angle in the middle because of vertical angles. 6 is my short side here, 24 is my short side on that triangle, 48 and 12 then will match. So I have to check, does 24 over 6, so I went top triangle over bottom, equal 48 over 12. And if that's true, then I'm good. And in both cases, those equal 4, so I'm good to go. And so this would be a yes by, and this is side angle side because that angle is tucked in between those sides. And I could say triangle EFG is similar to triangle E. Move along the short side to get to R and then S. All right. Moving on to number 16. When we look at this one, the key for this one is these parallel sides. So I have parallel sides here. I've got this transversal here, which means these two angles here and here are corresponding. So now I can go ahead and check, does 54 over 33, is that equivalent to 36 over 22? And so I can go ahead and check those two fractions. And so when I do 54 divided by 33, I get a value of 1.63, and both the 6 and the 3 repeat. And then 36 divided by 22, and I get the same thing. And so again, since those are exactly equivalent, I could say yes by side angle side, and I could say triangle CMP is similar to triangle RPQ. All right. Now I'm going to let you guys try the last one for yourselves, see what you guys come up with. Okay, so for this one, again, if it helps you, go ahead and draw out those two triangles. There's more than one way to do this, so don't feel like the way I'm doing it is the only way. It's just the way that I would probably expect that you would do it at this point. So if I look at this, I went ahead and labeled the two sides from the little triangle. Keep in mind, for W to S, that whole length is 45. The whole length from here to here is 14 plus 28, which gets you a value of 42. And so now we have this shared angle at W up here, so those are the same. And now I can go ahead and set up my proportions, 15 over 45, 14 over 42. So if I do 15 over 45, 14 over 42, in each case, you get 0.3 repeating for this one, 14 divided by 22, you get 0.3 repeating for this side. And so since those are equivalent and we have the angle between the two sides, this would be yes by side angle side. And then as far as your similarity statement, you would have WQR is similar to triangle W, and then moving down along this side, WSZ. Okay, so hopefully that provides a little bit of foundation. It's very similar to what we did for congruency. The only big difference that you have to be very mindful of is you have to check that those sides are indeed proportional, because if they're not, then they are not similar. All right, let me know if you have any questions. We're going to spend a little bit of time on this. So today your job is to go ahead and finish up the evens, and then we'll go from there. Thanks.